To read the citation of Professor Olubusoye, Olubusoye, Professor of Statistics, University of Ibadan. Professor Olubusoye stands as one of Nigeria's foremost statisticians and data scientists whose distinguished career spanning over 3 decades has significantly advanced statistical education, research, and policy applications across Africa. A scholar of exceptional caliber, he has demonstrated remarkable leadership in transforming statistical practice, fostering interdisciplinary collaboration, and building institutional capacity in statistics and data science. Appointed Professor of Statistics at the University of Ibadan in 2016, following his progression through the academic rank since joining the institution in 1995. Professor Olubusoye has established himself as a leading authority in econometric modeling, time series analysis, spatial statistics, and machine learning applications. His scholarly work bridges theoretical rigor with practical policy relevance, addressing critical development challenges in energy, economics, environmental sustainability, public health, and financial markets. Professor Olubusoye research portfolio exemplifies excellence and innovation with over 57 publications and in reputable international journals. His work has garnered 1,396 citations, biggest from reflecting substantial scholarly impact. His H index is of 17 and I-10 index of 27 testify to both the quality and the quantity of his contributions. His research specializes in energy economics, petroleum studies, African development, and public health applications, with particular expertise in COVID-19 pandemic modeling and environmental sustainability. His pioneering work includes 1. Developing novel methodologies for energy price forecasting using information-based uncertainty indexes with machine learning algorithm, advancing spatial regression and geostatistical methods for environmental and public health applications in Nigeria. 3. Creating innovative approaches to algorithmic debiasing in machine learning experiments, providing empirical evidence for renewable energy adoption and environmental policy in Africa. Recent publications in high-impact journals such as Energy Scientific Report, Quality and Quantity and Applied Economics demonstrate a sustained research productivity and relevance to contemporary global challenges. Now, his leadership and institutional development. Professor Olubusoye's visionary leadership has been instrumental in advancing statistical education and research infrastructure across Africa. As the founding coordinator of the University of Ibadan Laboratory for Interdisciplinary Statistical Analysis, UILISA, he has built a premier center for statistical collaboration that bridges academia, government, and industry. Through UILISA, he has secured substantial international grants and partnership, including from USAID, MacArthur Foundation, and European Union programs. His administrative leadership extends his current role as Director of Directorate of Quality Assurance, DPA, at the University of Ibadan. He has also served as second Vice President of the Nigerian Statistical Association and holds Chartered Statistician status from the Royal Statistical Society, London. Currently, he is the President of Nigeria Association of Microeconomic Modelers. Yeah. His teaching excellence and mentorship. He is an outstanding educator. Professor Olubusoye has taught and supervised at all academic levels. His teaching portfolio includes advanced courses in Bayesian statistics, econometric methods, statistical data mining, and machine learning applications. He has successfully supervised 24 PhD theses, 22 MSc dissertations, and mentored numerous early career researchers who have gone on to distinguished careers in academia, government, and industry. Its pedagogical innovation extends to developing specialized training programs for the Central Bank of Nigeria, where it regularly facilitates workshops on big data analytics and machine learning for monetary policy. Its commitment to statistical literacy is further evidenced by his popular radio program, Data Speaks, on Diamond FM, which brings statistical concepts to public audience. Professional and recognition service. Professor Olubusoye's expertise is widely sought both nationally and internationally. He serves as an external assessor for professorial promotions at numerous universities across Nigeria and Ghana, including the University of Ghana, University of Development Studies, and Tamil Technical University. This appointment reflects the high regard in which his academic judgment is held. His professional service includes membership on the Central Bank of Nigeria's Technical Working Committee and the Certification Committee of the Chartered Institute of Statisticians of Nigeria. He has also served as a consultant to international organizations, including the African Union Commission, World Bank, and African Development Bank, contributing to policy formulation and capacity building across the continent. Now, his awards and honors. Professor Olubusoye's contributions have been recognized through numerous awards and honors. There are many, but including some of them are first, Microsoft Research PhD Fellowship as Supervisor of Awardee 2021. International Statistical Institute Statistical Capacity Building Award 2020. Elected member, International Statistical Institute 2019. Exchange of Visitor to LISA, Virginia Tech and Purdue University, USA 2016. Visiting Scholars, International Monetary Fund, Washington, D.C. 2006. Multiple research grants from AERC, MacArthur Foundation, and USA. Legacy and impact. Professor Olubusoye's enduring legacy lies in his transformative impact on statistical practice in Africa. Through his research, teaching, and institutional leadership, he has elevated the standards of statistical education, fostered evidence-based policymaking, and built sustainable capacity for data-driven decision-making. His work exemplifies the highest ideals of academic excellence, social relevance, and professional integrity. As Africa confronts complex development challenges in the digital age, Professor Olubusoye's contribution provides essential tools and framework for harnessing data science and artificial intelligence for sustainable development. His career serves as an inspiring model of how academic expertise can drive positive transformation at institutional, national, and continental levels. With joy in our hearts and with a clapping ovation, join me as I welcome a scholar of distinction, a leader of vision, and a mentor of exceptional dedication, Professor Elisha Olubusoye. You are welcome, sir. Please be seated. Slap a bit fire. Between morning and afternoon. Good day. Let me start by thanking God and of course thanking Professor Bakari for giving me this very rare opportunity to be here. I also want to thank very eminent professors here, Professor Okoya, Professor Mrs. Okoya, and Professor Dayo Apata. We've been together for quite a while.
only that you disappear from the radar. Now you are found. Without wasting time, I would like to take us through a journey. That journey will take us from this knowledge of model to decisions. And that journey is also the same thing as saying the journey from the static point to the dynamic point. Because the word is, I will explain more as we go on. But basically, I want to drive home the point that we are in the world that is driven by data. That the modern day, two things actually drive development in this age. One is technology. The other one is data. And these two, they go together because technology actually helps to generate data. When you see traffic light, in some cases, sensors and so on like that, even your phone that you carry is a technology, but imagine the number of pictures you have taken this morning, today, or since this program started, the number of messages that you have sent. So technology is a major driver of data. And it has also led to a shift. So I will be discussing about the shift with the real world, that shift from evidence, from risk, from fraud, from energy, or anomaly detection. So my overall goal actually is to show how machine learning in particular is not just a tool, but is a paradigm shift. That machine learning that we keep on talking about, so it's a paradigm shift in how we move from models to decisions. So in my talk, I will start by tracing the theoretical evolution of applied mathematics. Don't take me as an authority in this area. Professor Apoya is the authority, but I can lean on his shoulder to say some things. So I will just say a few things about that theoretical evolution. Then I will discuss the transition from model to decisions. And then how output from our models can form the basis for actionable insights. Our model is not just to run model, but it's supposed to take us beyond the result to taking actions. And so I will demonstrate with 2 case studies, but because of time, I might skip one of them, one to save time. But the one that may interest you is the second case study, which actually has something to do with the University of Ibadan. regarding energy anomaly detection. Then we would touch on responsible decision makings. I will conclude with what I consider to be the future directions. Now, historically, applied mathematics was built on what we call classical paradigm. And that classical paradigm is defined by these three things. Theory first, assumption heavy, which Prof proved yesterday. You have theory, so you are sound in the theory. And then have very rigorous, sometimes difficult assumptions. And like Prof said yesterday, the idea is to simplify the problem. So that's where we were coming from. The other thing that defined that classical is that we were always after closed form solutions. These models were elegant, there's no doubt about that. But unfortunately, they are fragile. Why are they fragile? They are really updated. And they are prone to what we call model decay when they face a dynamic environment. And when we say model decay, I will try to explain most of these concepts for everyone to understand. When we say model decay in dynamic environment, we simply mean that a statistical or a machine learning model performance deteriorates over time. That you build a model today, over time, the performance of that model, if the model is not maintained and updated, the performance of that model will deteriorate. Why is it deteriorating? It's deteriorating because the real world data that we use, we always encounter changes. And that changes is what we call concept drift. Concept drift. So when there is a change, the way we used to, we've talked a lot about many things. The way we do a lot of things has continued to change because of technology, for instance, which I mentioned. So to address this concept shift, we are now moving from the classical paradigm to what I now call the modern shift. And the modern shift is when we adopt adaptive learning system. Adaptive learning system is one that learn from data in real time, unlike the classical where you already have a closed form solution, which is also not capturing the changes, the shift, the concept shift that I mentioned about. So the problem is that the classical often assume that the world is stationary, that the world is not changing. But the current shift is acknowledging the fact that the world is in a continuous change. So the life is changing. I hope I'm communicating. So the question is, what are the drivers? What are those things causing this change? Why this concept shift from classical, right, no, to the modern? Why? So three forces can be attributed. Maybe all other forces can come under. First is the explosion of data. We are no longer dealing with small data. We are no longer dealing with curated data samples. But like all of you will define big data, we are dealing with high velocity multidimensional data, whether in the cell, genetic, wherever, you are dealing with very massive amount of data. So, unlike before, you handle very limited amount of data, which you use your calculator or the logarithm table at best, and then calculator, and then, now. The other thing that is bringing about the change is the computing power. The development of graphics processing units and parallel processing enable us to solve optimization problems that were not were difficult previously, if not impossible. So GPUs, they are the hardware engines behind the fast and large-scale machine learning and real-time analytics that we now do. The third reason for this change is the fact that data are coming in real time, and decision makers, businesses, institutions no longer want monthly report. They want on the spot information to make decisions. So they need millisecond level decisions. So this trial has reshaped what's possible in applied mathematics. So applied mathematics, of course, most people will also classify statistics as applied mathematics, fine, but it's about data. So let's contrast the theoretical evolution with, or rather, let's contrast the tradition and the modern. As a matter of fact, the transition is what I call the solver era. That's the time we look for closed form solutions. And the modern is what I call the architect era. This is very important for us, those of us that are just coming, to understand that we are in a new era. We are coming from addition. and we are in a completely new situation, new world. So we can compare the two. In the solver or in the traditional era, as I said earlier, focus is on closed form solutions. We use p-values a lot. How many of us use p-values? We use p-values a lot. In fact, I've had to give a talk on significant or not significant, the controversy surrounding p-values. When you hear most studies, in fact, people have, so many researchers, they have won laurel because of p-value. But now we discover that most of the studies that made them to win those laurels are not reproducible. The p-values are not reproducible. And science, one of the hallmark of science is that reproducibility of the study. If you start all over again, you must be able to the same result, get the same result, and also arrive at the same findings. But it's been discovered that in the traditional era, we brandish p-values. Even in some of our departments and so on, it's still about, is it significant? Is it not significant? But we are moving beyond that. We also look at goodness of fit. Seen many presentations, AIC, BIC, those are, yeah. So models were static at that time and manually calibrated. Today, in the architect era, we prioritize predictive utility, flexible algorithms, and continuous feedback. Those are the hallmarks of the modern era. So we moved from proving theories to optimizing decisions. The measure of success is no longer just statistical significance. So we emphasize on practical significance. So when I teach now, I make distinction between statistical significance and practical significance. There is a wide gap between the two. Can be statistically significant when it does not even have any practical significance. And a very common example is, I don't drink beer, for instance, but suppose I'm forced to drink, maybe one bottle will make me go intoxicated, right? Maybe one bottle will change my, thinking system. That would be very significant. But when you now, for somebody who can drink a carton, and one bottle be significant. So when we bring significance, we emphasize not on the statistics, I'm a statistician, not on the statistical significance, but on the what? So our emphasis is the measure of the impacts. So even in statistics, we talk about effect size. We talk about effect size. Sorry. not responding. Okay. And this is very critical, very important. I've talked about the shift, but I want to also lay emphasis that despite the shift from theory first to data first, the foundations remain deeply mathematical. Did you hear me? The foundation, what? Deeply remains mathematical. Despite that, we are shifting. There is a shift from theory based to data, to theory first to data first. Optimization, for instance, gradient, descent, convex optimizations, power line, all of that, that we use in machine learning, they help to find the best model parameters that minimize error loss or maximize performance. So we still use all the optimization techniques, but now is to find the best model parameters. Two, we still use our linear algebra, whether we are using singular value decomposition or matrix factorization. We use them to help us navigate high dimensional spaces. We still use probability, and we've talked about this. Bayesian inference, uncertainty quantification, all of this allows us to manage risk. So let me put a sound of warning that machine learning is not a departure from mathematics. I hope we agree. It's not a departure. In fact, the foundation is what? Mathematics. So we can conveniently, without enduring anybody's, that it's an extension to it's an extension of into data-rich domain. Machine learning is an extension of mathematics into what? Data-rich domain. That is how I want to see it. And that takes us to where we are going. Once I give this foundation, I will take the application and we are good to go. This is the chain of action from models to what? Outputs, and from outputs to decision. This is the core of our talk. This is the core of our discussion. How we move from building models to making decisions. Models like anomaly detectors or forecasters, they produce structural signals. Some of them will give you, for instance, risk scores, alerts, and intervals. Those things are calling for actions. When you have a model that is giving you signal or giving you the measure of risk and so on. So those actions from the output, they are often operationalized into automated actions rather than just getting the output. The actions are also automated, that once you have this value, then alarm signal should flow. Are you with me now? That's the state that we need. Once a car, maybe you put your sensor at the gate and it's automated, and or you go to a bank and you want to apply for loan and you submit your details, and the system, the machine learning, the algorithm runs on it, and quickly you see the decision. You are not eligible to apply. Or you put your card into the dispensing machine and say, the alert is given at the back end. This card is stolen. You are at the airport, you suddenly, if you have been traveling at the airport, among hundreds of thousands of travelers, you don't say, Olubusoye, Olubusoye, report to so. Your package has been scanned, your visa has been scanned, everything, in fact, but they have isolated your luggage. Are you with me? This person should be properly screened. Then humans will now come and do the screen. That is the hate. I hope you are getting the communication. So that is the hate we have. What do you think is working on that net? It is the algorithm. And you don't have to wait till next week before you know a traveler, a suicide bomber, already body or boarded before you now start looking for solution. So if you are thinking of any problem right now, it's a problem that we take you from model to output to what? To real-time decision making. Then you are contributing. That is where we are doing. That is where we should be. That's where we should be. And this is when this pipeline model output to decision, this is when it turns our analytics into something that is valuable. Turns our analytics into something that you can take actionable insights. So, with that background, I will, because of time, skip to the example that I want to show, and then we I'm going to skip this. Yes, this one should interest you, and it's about electricity consumption's anomaly. For some time, I'm sure you've heard about universities groaning, complaining about the energy cost, how much they pay to the discos. UI at the time also was under that serious burden. So what we did was to gather 12 years of smart data from the University of Ibadan residential areas. And we were able to gather transaction data for 138,310. We focused only on the residential areas. And the issue was that it was discovered that in some residential areas, people were even bypassing professors bypassing energy, not to pay. The same thing with non-academic, you go to, if you know Aberdeen area and so on, they bypass electricity. So a lot of sharp practices were going on. So that led to this. Actually, this study was done by one of my master's students, and the university operated, and that's why we were able to access the data. So the scale of this data set is substantial. If you look at the total amount involved in this transaction, how many of you have this in your account? 449 million. That's the amount involved. And we found that on average, 1,528 transactions were made. What happened is that customers, they come buy the units and load on the digital meter. And on average, 4 million or close to 5 million was realized. So this represents significant energy consumption. And if we are able to optimize, that will yield substantial cost saving and efficiency improvement for the university. So our goal was to detect anomalies like meter tampering or billing discrepancies. That was the main objective. So we applied, these were the methods we applied. The set score, that is standardized score, the interquartile range, that's IQR, the DB scan, density-based spatial clustering or applications with noise, isolation for rest, and then we use R and Python for the implementation. So, different methods, of course, from the table you see here, different methods actually yielded different anomaly rates. For instance, the Z-score yielded 34.93%, 14.95%. The standardized score yielded 39.93% with interquartile range. The consensus approach yielded 22.11. So we use the TSNE visualization. TSNE is T distributed stochastic neighbor embedding. So this layered of approach, you use multiple approach. The objective is to ensure robustness of our findings. And the TSNE visualization provides an intuitive way to understand how anomalies differ from normal consumption patterns. If you look at it, maybe from where you are seated, you will see some spots, red ones, and you also see the hash ones. So the red points suggest that you can see the scattered nature of the red points, and that suggests that diverse types of anomalies rather than a single pattern of irregular behavior. So seeing them being scattered is saying that the nature of the anomaly is not unique, that different anomalies, different approaches are used by the customers to um, to 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 beat the system, to be able to avoid paying for the electricity they consume. So it's not one approach they use. That's what that scatter point is. So, and the advantage of using this type of visualization is that it helps energy managers to quickly identify which accounts warrant immediate attention or not. You will also notice here that we have the electricity clustering behavior. We have different clusters depicting the electricity consumption pattern. We have over 90 accounts in cluster 1, and those represent group of electricity consumers with high consumption level. So we are able to categorize them. Then we also able to categorize 2, 2, 4 as moderate electricity consumers. And quite a big, a good number, 1,097 happen to be low consumers. So this group represents different behavioral groups of electricity consumers at the University of Ibadan. So you have high consumption consumer, moderate, low, stable. But before I leave that, maybe you will notice that the clustering revealed that most accounts fall into low, which I mentioned, which is expected for residential settings. However, if you look at the high consumption, they also have high variability. And this is interesting. The fact that they have high variability, this could be accounts with unusual usage pattern. Their potential, group to monitor. They could be commercial, they could be doing commercial activities, even within the within the resident. Maybe they are grinding pepper, using a shop, out later. So, but what this will help the authority to do is to identify those groups and then track them and do further investigation about their activity. They would need to know, but behind the algorithm will always be showing that these people should be investigated. So we use multiple validation methods, as you can see on the screen. The idea of validating is to strengthen the confidence in the result, particularly in the 3-cluster solution that we arrived at. You will see the able method shows diminishing returns beyond after 3 clusters. You will see after 3 clusters, this is the one, and this one, after 3 clusters, you can see the plot going down. So the box plot clearly demonstrate how those in cluster 1 accounts differ dramatically from other groups. If you look at that's the left. This is the cluster. You will see these are the group in cluster 1, and all through they show they are different from the remaining other two. They show different behavior from the other two groups, and that put them on the suspect list. Okay. Not only do they have higher average consumption in terms of media, but they also, in terms of the variability, they have more transactions. Variability is measured by the size of that, because it's looking at the range between the upper quartile and the lower quartile. So this pattern could indicate multiple residents sharing a meter, irregular occupancy pattern, or potentially unauthorized usage that merits further investigation or detailed auditing. And we also, I think I've spoken about this. This is the final, so to say, output. We then listed the 52 accounts that we found to be anonymous. And these are the accounts. If you live in UI, maybe your account is there. So, but what are we trying to say with that? Your model should lead to actionable insights. That's the bottom line of this presentation. It shouldn't be so dicey, so crowded. You cannot, the policymaker is not able to see what action should I take now. What should I do now? When you have used battalion of techniques and models and approaches, yes. At the end, you remember the pipeline from model to output to what? The decisions. That's what and then what's happening? So these are the key findings, but I'm not going to, some of them we've discussed, so to save our time. So that takes us to the most important part, and that is the human in the loop and governance. All our model must have the human factor. Animals will not run the model. Animals are not the ones that will take decisions. Human beings are the ones. They are the rational. They are the rational beings. They are the ones who can think, who can So whether in fraud or energy, decision must be responsible, which means we must maintain human in the loop system. Experts will review high-risk flags, escalation pathways. Every decision is carefully documented. Every step, every stage. Always, of course, I think we've talked about it, reproducibility and replicability. These are the core, features of science. Models are auditable across versions. You can always have version of your model. So not that you have one model today, you can always, even those in technology, you upgrade, isn't it? You upgrade our phones, you upgrade from laptops, but you must that is maintenance. Keeping your model very active. If you are building model, today you build model for malaria, tomorrow you are building model for typhoid fever, because if you keep on building models, like I said earlier, all those models will suffer decay. They will deteriorate in terms of the output they will be generating. And that's what's taking us from the old era to the modern era. Models are auditable across versions, so it's not just an ethical issue, it's the operational best practices. So, what should we look forward to? What should we expect in the future? Looking ahead, I can see three key directions. One is graph-based learning. Two is online learning. And three is connected, adaptive, governed system that operate end to end. The graph-based learning will detect coordinated fraud through rational networks. You know those fraudsters. Fraud is a real event, right? Yeah. Out of all of us here, those who likely perpetrate fraud maybe just few. But it's also a racket. It's not only one person. Sometimes we need a model that will be able to connect and coordinate networks. Are you with me? If you are specializing in fraud detection models and things like that, then online learning for real-time model adaptation, the purpose of the online is to allow your model to adjust quickly so that there is no lag, because we are all operating now on two spaces. We are operating on the physical space. We are also operating on the virtual space. Two of us. If you are still only in the physical space, we've taken your position in the virtual space. Because I used to, when I talk to my colleagues in Nigeria area spaces, who is occupying our space in the in the space? Maybe those who are there first, they have already done the CFO. So we are not in a hurry, but they are there. They have marked every place, including our own. So when we are ready and we now get there, we have been here before. So the future is not just automated, it must be intelligently adaptive. It's not just to be able to detect, it must also be able to respond to emerging threats. Because when you have a way of practicing fraud and you are detected, people change. Yeah. They change quickly. And they are so gifted. So gifted in the way they change the whole thing. If your model is designed only to detect old habits, when the new habit comes, it's obsolete. It's obsolete. So to summarize this lecture, applied mathematics is evolving from static models to adaptive, data-driven systems. Machine learning enables us to make real-time, high-stakes decisions in domains like fraud, energy. Not only there are so many areas, but with this power comes responsibility. We must, in fact, in Europe, all these algorithms, all these things, when you build your algorithm, you must be responsible. You must take responsibility of what happens. That's where when you are using some of these applications, you see full disclosure. If you are now ready, you click yes, you subscribe. Once you tie your own hand, but taking responsibility is very important. So you must be, the model must be, that's why we talk about explainable AI, not one that you cannot explain how data enters and how output comes out. So there must be oversight. That's the essence of the human. There must be governance. Eh? Governance that are non-negotiable. The case studies today show that this shift is not just theoretical. It is delivering tangible impact. And I think on this, I want to say thank you. Kind attention. If you have time, please, you can visit my YouTube channel. Just Google for Olubusoye.
Wow.
You will see quite a number of videos there that can help you for those who are, wants to know more. Thank you very much.
Please, can we put our hands together once more?